Today's experiment is aldol condensation. The main reaction in this experiment is mixed aldol condensation to synthesize dibenzylacetone. 1 mole of acetone will react with 2 moles of benzaldehyde with sodium hydroxide to produce dibenzylacetone. The first step in the synthesis of dibenzylacetone is the formation of the enolate ion, which is highly resonance stabilized. The hydroxide ion on the NaOH will attack the alpha hydrogen, pushing those electrons onto the alpha carbon, and this will form the highly resonance stabilized enolate ion. Either one of the resonance structures of the enolate ion can be used to attack the carbonyl carbon of the first mole of benzaldehyde. This will break the pi bond and push the lone pair onto the oxygen. The now negatively charged oxygen will attack a hydrogen of the water molecule and form a hydroxide ion. The hydroxide ion can then attack the acidic hydrogen and form a double bond, making the hydroxyl group leave. The hydroxide ion will then attack the alpha hydrogen and push those electrons onto the alpha carbon. That lone pair can then attack the carbonyl carbon of the second mole of benzaldehyde, break that pi bond, and push those electrons onto the oxygen. And again, the negatively charged oxygen will pick up a hydrogen from the water molecule, giving us another hydroxide ion. This hydroxide ion can then again attack the acidic hydrogen, forming a double bond and again allowing the hydroxyl group to leave. This will give us dibenzylacetone, which is our desired product in this experiment. There's a possible side reaction that can occur. No alpha hydrogens can be present for this. It's called the Cannizaro reaction, in which 2 moles of benzaldehyde react with sodium hydroxide to produce sodium benzoate and benzyl alcohol. The hydroxide ion will first attack the carbonyl carbon of the first mole of benzaldehyde, break the pi bond, and push those electrons onto the oxygen. That oxygen, now negatively charged, will come down and form a pi bond, and the electrons in the carbon-hydrogen bond will be used to attack the carbonyl carbon of the second mole of benzaldehyde, breaking that pi bond and pushing those electrons onto the oxygen. This will give us 2 products here. In the first, the hydroxide ion will attack the hydrogen of the hydroxyl group and push those electrons onto the oxygen. This will give us sodium benzoate, our first product. For the second product, the previously formed water molecule will be attacked by the negatively charged oxygen to give hydroxide, and this will give us our second product, benzyl alcohol.